Good day. Welcome to GE 6114 Mathematics and the Modern World. For week 9, our topic is linear regression and correlation. So let's have first correlation. What is correlation? It is a technique used to measure the likelihood of two behaviors relating to each other. According to Guilford, a coefficient of correlation is a single number that tells us to what extent two things are related, to what extent variation in one go with variations in the other. It means that correlation is a mathematical technique or specifically a statistical technique to determine if there is a significant relationship between two given variables. There are types of correlation. The scatter plot explains the correlation between the two attributes of or variables. It represents how closely the two variables are connected, and there can be three such situations to see the relation between the two variables. The first one is what we call positive correlation. It's when the value of one variable increases with respect to other. So, kumbaga sa mathematics, we call it directly proportional. As the value of the independent variable x increases, the value of y, the dependent variable, also increases. With that situation, we call it positive correlation. It means that the variable x and the variable y has a positive correlation. The second is negative correlation, when the value of one variable decreases with respect to another. So in mathematics, we call it inversely proportional. As the value of the variable x or the independent variable increases, the value of y or the dependent variable decreases. It means that x and y has a negative correlation in such a way that when the value of the other variable increases, the other one decreases. Reverse. The third one is no correlation, when there is no linear dependence or no relation between the two variables. So it will happen if the value of the coefficient of correlation is equal to 0. So it means that the two variables has no relationship at all. Here is the example of a scatter plot. The first figure shows a strong positive correlation. You can see that the linear graph is increasing to the right and decreasing to the left. It means that the graph has a positive slope, which means that the variables or that the points in the graph are increasing. The second figure is weak positive correlation. In this case, you can see that the points are a little bit away from the linear graph. Next is strong negative correlation. So the slope here is negative since the graph or the line is increasing to the left and decreasing to the right. Fourth is weak negative correlation. Yan, medyo malalayo din yung mga points sa linear line. Then we have moderate negative correlation. Medyo malapit-lapit na siya. And then we have the no correlation at all. Very scattered na yung location ng mga points. Medyo malalayo na siya. We have first here, statistical test for correlation, what we call Pearson correlation coefficient. We call it sometimes the Pearson product moment correlation or the Pearson R. In statistics, the Pearson correlation coefficient, also referred to as Pearson's R, the Pearson product moment correlation coefficient or the bivariate correlation, is a statistic that measures linear correlation between two variables x and y. It has a value between positive 1 and negative 1. So yung sinabi ko kanina, the value of the Pearson R or the coefficient of correlation R ranges from negative 1 to positive 1. So hindi siya pwedeng sumobra dyan sa positive 1 and negative 1. Hindi pwedeng maging negative 2, hindi pwedeng maging positive 2. So the formula for the Pearson R is given by this, wherein variable R represents correlation coefficient, x sub I, values of the x variable in a sample, x bar, means of the values of the x variable or mean of the values of the x variable, y sub I, values of the y variable in a sample, and we have here the y bar or the mean of the values of the y variable. And we also have here the indicators or yung value, your interpretation. If the value of the Pearson R, or the coefficient of correlation R, is 0 to 0.3, we're going to neglect the correlation. It means pwede na natin sabihin na there's no correlation if the value of R is from 0.0 to 0.3. Then we have here from 0.3 to 0.5, low positive negative correlation or positive correlation, either of the two. If the value is positive, it has low positive correlation. If the value is negative, we have low negative correlation. Third is 0.5 to 0.7. We have moderate correlation, either positive or negative. And then 0.7 to 0.9, we have high positive correlation. And then 0.9 to positive 1 or negative 1, we have very high positive correlation. I repeat, 0.9 to 1 or negative 0.9 to 1, we have very high positive or very high negative correlation. 0.7 to 0.9 or negative 0.7 to negative 0.9, we have high positive correlation. 0.5 to 0.7 or negative 0.5 to negative 0.7, we have moderate positive or moderate negative correlation. 0.3 to 0.5 or negative 0.3 to negative 0.5, we have low positive correlation. And then 0 to 0.3 or 0 to negative 0.3, we have a negligible correlation. The Pearson product moment correlation coefficient, or the Pearson correlation coefficient for short, is a measure of the strength of a linear association between two variables and is denoted by the small letter R. Basically, a Pearson product moment correlation attempts to draw a line of the best fit through the data of two variables. In the Pearson correlation, R indicates how far away all these data points are to this line of best fit. Okay. So we have here the best fit. Yung line na tinutukoy dyan or sinasabi dyan is yung linear line kanina sa scatter plot. The example, find the value of the correlation coefficient from the following table. So we have here the first column, subject, and we have subjects 1, 2, 3, 4, 5, and 6. And we have the second column, age, variable X. We have 43, 21, 25, 42, 57, and 59. And we have the third column, glucose level Y, or variable Y. We have 99, 65, 79, 75, 87, and 81. The first step to solve for the Pearson R is to make a chart and use the given data and then add three more columns. Given the XY, or the product of X and Y variable, this one. We also have the X squared column and then the Y squared. So, gagawa tayo ng, or mag-add tayo ng tatlong columns. We have the XY. We're going to multiply the value of variable X and then variable Y. We also have the square of X and then the square of Y. Okay, so first we have to get the product of X and Y, or the column for X and Y variable. So we have to multiply 43 times 99, we have 4,257. 21 times 65 is 1365. 25 times 79 is 1975. 42 times 75 is 3150. And then 57 times 87 is 4959. And then 59 times 81 is 4779. So we just multiply the value of the variable X and variable Y per row. So we have here now the value of each column. Now we have to add up, or we have to get the summation of each column. So for the variable X, the summation or the total of the values of the X variables, we have 43, 21, 25, 42, 57, 59. If we add up all these values, we will get, or we get 247. Then for column of Y, we get a total of 486. For XY column, we have a total of 20,485. For X squared, we have 11,409. And for Y squared, we have 40,022. Now for step 6, use the following correlation coefficient formula. So this formula is derived from the original formula, yung present natin kanina for the value for the formula for Pearson R. So we have here the formula R is equal to n times the summation of xy minus summation of x times the summation of y divided by the square root of the quantity of n times the summation of x squared minus the summation of x squared times n times summation of y squared minus summation of y squared. And we have here the values kanina sa step 5. Summation of x is 247. Summation of y is 486. Summation of xy is 20,485. Summation of x squared is 11,409. And summation of y squared is 40,022. And n is the sample size. In our case, we have 6 subjects. So the correlation coefficient, if we substitute all these values to the formula, we have n, which is 6 times 20,485, the summation of xy, minus 247, summation of x, and then times summation of y, which is 486, divided by the square root of n times summation of x squared, 11,409, minus summation of x squared. Summation of x is 247 squared times 6 times summation of y squared, 40,022, minus the summation of y, 486 squared. And then we will get a value of r, which is 0.5298. Or if we simplify this, that's 2,868 divided by 5,413.25, which is 0.529809. So this is the value of the variable r, or the Pearson r. So if we recall the indicators, the range of the correlation coefficient is from -1 to 1. So our result is 0.5298, or that is 52.98%, which means that the variables have a moderate positive correlation. So this was based from the indicator table for interpreting the value of the coefficient or Pearson r. Okay, so let's have now simple linear regression. Simple linear regression analysis is a technique that is used to model the dependency of one dependent variable upon one independent variable. This relationship between these two variables is explained by an equation. Regression and correlation are actually fundamentally the same statistical procedure. The difference is essentially in what your purpose is, what you're trying to find out. In correlation, we are generally looking at the strength of a relationship between two variables x and y. Wherein regression, we are specifically concerned with how well we can predict y from x. Only one independent variable x. Relationship between y and x is described by a linear function. Changes in y are assumed to be caused by changes in x. So simple linear regression is a way of creating a model to determine the value of y given the value of x. Examples for the use of regression in education research include defining and identifying underachievement or specific learning difficulties. And for example, by determining whether a pupil's reading attainment, variable y, is at the level that would be predicted from an IQ test, variable x. Another example would be screening tests, perhaps to identify children at risk of later educational failure so that they may receive additional support or be involved in early intervention schemes. In regression, it is convenient to define variable x as the explanatory or predictor or the independent variable, and y as the outcome or the dependent variable. We are concerned with determining how well x variable can predict y variable. So we are now trying to forecast if we can forecast or predict the value of the variable y given the value of the variable x. It is important to know which variable is the line that minimizes the differences between the actual y values and the y value that would be predicted from the line. These differences are squared so that negative signs are removed. Hence, the term sum of squares, which you have come across before. The line has the formula y is equal to a plus bx, where a is the intercept, the point where the line meets the y-axis, where x is equal to 0. So this is the intercept, the value of a. Then, and b is the slope or the gradient of the line, the amount y increases for each unit increase in x. So this is the slope. And then, figure 2.5.3 shows that for this example, the intercept where the line meets the y-axis is 2.4. Ito yun. The slope is 1.31, meaning for every unit increase in x, an increase of 1. The predicted value of y increases by 1.31. This value would have a negative sign if the correlation was negative. The regression line represents the predicted value of y for each value of x. We can use it to generate a predicted value of y for any given value of x using our formula. Even if we don't have a specific data point that covers the value from figure 2.5.3, we see that an x value of 3.5 predicts a y value of about 7. Then, of course, the model is not perfect. The vertical distance from each data point to the regression line, which is shown in figure 2.5.2, represents the error of prediction. These errors are called residuals. We call it residuals, the excess. We can take the average of these errors to get a measure of the average amount that the regression equation overpredicts or underpredicts the y values. The higher the correlation, the smaller these errors or residuals, and the more accurate the predictions are likely to be called. So it means that the lower the residuals or this line, yung green na yan, the higher the correlation. The equation has the form y is equal to a plus bx, where y is the dependent variable. That's the variable that goes on the y-axis. And then x is the independent variable. It is plotted on the x-axis. B is the slope of the line, and a is the y-intercept. So the general equation for simple linear regression is given by y is equal to a plus bx. Or we can interchange that to y is equal to bx plus a. So here are the assumptions of simple regression. 1, the linearity, the mean of each error is 0. 2, independence of error terms. The errors are independent of each other. 3, normality of error terms. The error of each variable is normally distributed. 4, homoscedasticity. The variance of the error for the value of each variable is the same. So these are the 4 assumptions for simple regression. I repeat. First, the linearity, the mean of each error is 0. Second, independence of error terms. The errors are independent of each other. Third, the normality of error terms. The error of each variable is normally distributed. Fourth, homoscedasticity. The variance of the error for the value of each variable is the same. Simple linear regression, math by hand. So there are just a handful of steps in linear regression. First, compute for the x, y, or the product of the x variable and the y variable. Second, square the values of x and y. Third, find the summation of x, y, x squared, and y squared. Fourth, solve for the slope. Fifth, solve for the intercept. And lastly, substitute the values to the regression formula to determine y is equal to mx plus b or y is equal to a plus bx. So mx and bx are just the same, and then a and b are just the same. The least squares line has 2 components, the slope m and the y-intercept b. We will solve for m first and then solve for b. The equations for m and b are given below. So these are the formula or the equations for the slope m or the coefficient of the slope m and then the intercept b. So the formula for the slope m is given by n times the summation of xy minus summation of x times summation of y all over n times summation of x squared minus summation of x squared. And then for the intercept b, we have summation of y minus m times summation of x all over n. So since we're going to use the value of m to solve for the value of b, it means that we cannot get the value of b without solving first for the value of m. So it is a must that we solve first for the value of the slope m before getting the value of the intercept b. Okay, so example, we have here in the first column number of chimpanzees, x variable, then percent successful hunts, y variable. And we have here the product of x and y, the square of x and the square of y. So given na yung mga values na yan, and we get the summation of the x variable is 36, summation of the y variable 449, summation of product of xy 2249, summation of x squared 204, summation of y squared is 26,541. And then Let's solve for the value of the slope m. So for the slope m, we have n times summation of xy minus summation of x times summation of y divided by n times summation of x squared minus summation of x squared. Then we substitute the values, and we have 8. Ito yun. We have here n is equal to 8. This one. And then we have here the summation of y, summation of x, summation of y. Then summation of xy, summation of x squared, then summation of y squared. So 8 times summation of xy is 2,249 minus summation of x is 36 times summation of y is 449 divided by 8 times the summation of x squared, 204. Summation of x squared is 36 squared. So we have here the value of the slope m, 5.4405. And after that, we solve for the value of b. So we have here b is equal to the summation of y minus m, or the slope, times summation of x divided by n. We have 449 for the summation of y minus the slope, 5.4405 times the value of summation of x, which is 36, divided by n, which is 8. So we get the value of b, or the intercept, 31.6429. So the next step is to substitute these values, value of m and value of b, to the equation for the simple linear regression. So we have y is equal to mx plus b, and y is equal to 5.4405x plus 316429. So it means this is the equation to predict the value of y given the value of x. So there you have it. You can make predictions of y from given values of x using your equation y is equal to 5.4405x plus 31.6429. This means that our line starts out at 31.6429 and the y values increase by 5.4405 percentage points for every one chimpanzee that joins the hunting party. To test this out, let's predict the percent hunt success for chimpanzees. So let's substitute the value of, let's substitute 4 to the variable x. So kapag nilagay natin yung 4 sa variable x, we will get a value of y which is 53.4. So na-predict natin ang value ng y if there are 4 chimpanzees as the value of x. And then, for example, you want to know how strong is the relationship of the exam grade on the number of words in the student's essay. The data is below. So we have here number of students from 1 to 12. So we have here 12 students. Their grade, and then the number of words on their essay. So for example, the student 1 got a grade of 79, and the number of words he or she used in his or her essay is 147. Then, using computer, we usually use Excel. The slope is 3.74. Then, x times exam grade is 85. X or exam grade is equal to 85.75, and y, or the words in essay, is 176.25. Then, this is the mean grade, and then mean words on essay. This is the mean grade, and this is the mean number of words used in essay, or this is the x bar and this is the y bar. X bar is 85.75 and y bar is 176.25. Then compute the intercept using the Excel or the computer. We have b is equal to negative 145.27. Then step 4, create linear regression equation. So y, words on essay, is equal to 3.74, the slope, times the exam grade or the variable x minus the intercept 145.27. Or that is y is equal to 3.74x minus 145.27. So note, you can use this equation to predict the number of words on the essay if you know the exam grade, or to predict the exam grade if you know how many words they wrote in the essay. It is a simple algebra. So we can manipulate this if the given is the exam grade or the given is the words on essay. If the given is exam grade, we can predict the number of words on essay, or if the given is the number of words on essay, we can predict the exam grade, as long as the slope and the intercept are constant or are given. So in the previous computation, slope is 3.74, The variable X exam grade or the mean exam grade is 85.75, and the mean Y or mean number of words in essay is 176.25. Then the intercept is negative 145.27. So calculate the coefficient of determination R squared, and computer does it for you. So we have here R squared is 0.85. So the coefficient of determination explains 85% of the variation in the number of words on the essay. In other words, exam grades strongly predict how many words a student will write in their essay. And that's it. So that ends the lesson for week 9, correlation and simple linear regression. Thank you.